Welcome to this workshop on Introduction to Network Automation using Ansible. My name is Ganesh Nalawade. I work as Principal Software Engineer in Ansible Engineering team. I'm based out of Pune in India, and my GitHub and IIS unique is Ganesh Aran, and I'm Ganesh @Ganesh634 on Twitter. So let's get started. This is our agenda for today's workshop. We'll be going through Ansible overview. First, we'll talk about some of the basic introductory stuff, like how module execution happens with Linux versus network host. Then we'll do an introductory session on what are Ansible collections, and we'll talk about network collections in specific. After that, we'll move on to fundamental modules for network. How can you run certain commands, operational commands, config commands, get facts from network devices. Then we'll talk about resource module for config management on network devices. Then we'll talk about a couple of modules that will deal with operational state management using Ansible. So Ansible is simple, powerful, agent list. First is simple. Everyone can learn it and use it almost immediately in order to automate the task they do today. Since most network engineers wouldn't consider coding or application development as a core competence, the framework that Ansible provides make it easy for network engineers to convert how policies, what they are familiar with, map to the task, which get then automated and executed in order. The way Ansible playbooks are written and run can be implemented the same way the switch is installed, provisioned, configured, and maintained in production environment. What makes Ansible powerful? It is designed and built for flexibility to enable the entire data center. The underlying Ansible architecture and automation engine, which we'll go through later, enables for development of modules, plugins to extend functionality without boundaries. The root of Ansible started in server world, but now it is quickly adopted to network world because of its ability to operationalize automation in existing networking CLIs, as well as create bridges to the DevOps world in next-gen network. And the next best part is it is agentless. So there is one less application to worry about, especially if you have to install a third-party application on a network device, which are more restricted or have more restricted execution environment. Moving on. This is a very brief overview of how the Ansible architecture looks like. The user here makes everything possible. They can be network engineers or operators that write Ansible playbooks that feed them into Ansible automation engine for execution. So the Ansible playbook is being fed to Ansible automation engine. Ansible automation engine consists of 4 key components. First is the inventory. Inventory is a collection of endpoints being managed. For example, they can be switches, firewall, router, server, virtual machines, cloud devices, container, etc. As long as the instance can be connected to via API, SSH, or WinRM, they can be managed using Ansible's inventory. Module is an integral piece of network infrastructure. Module controls system resources, services, packages, files. They handle executing system commands. Not a lot of significant changes were made to underlying Ansible code to enable networking devices, but instead focus was put on enabling vendors to leverage platform-specific features and functionality through the development of their Ansible modules. We'll go to a couple of Ansible modules in our coming slide. There are thousands of Ansible modules right now available that are built by community, the Ansible team, and vendors that you can use to automate your infrastructure. Then plugins is a piece of code that augment Ansible's core functionality. For example, connection plugin define how to communicate with an inventory host. You can have SSH-based connection, netcom-based connection, or a HTTP-based connection. So Ansible is basically used to augment the skill sets that network operators have. And it is not required for network operators to be a full-time software developer to get started with Ansible. That is one of the main unique points for Ansible with network automation. So moving on, we'll talk about module execution a bit. For a Linux system for managed host, it generally has execution environment wherein Python is installed on the remote host. So Ansible works a bit differently for Linux. It basically copies the module files that basically does the task onto the management task onto the remote host, onto the remote system, and it executes the Python file onto the remote system and fetches the result back, which is then displayed to the user. But when it comes to network, since networking devices don't have execution environments or Python installed onto their box, it is not recommended to copy the Python scripts onto the networking device. So in this case, the modules are run on the control node, and on the control node, it uses various connections to connect to the remote host, and then execute the command and fetches the response back. So this slide talks about what are all the connection types that are specific to networking. First one is the famous or most widely used is the SSH connection. So we have a network CLI connection that is built on top of SSH. It basically spawns the pseudo terminal with the device from the control node, and then it sends over the command through that terminal and gets the response back. Then we can communicate through API. So vendors have their own APIs. For example, Cisco has an XOS API, Arista has eAPI. So there are connection plugins available to connect through those APIs. Then netconf is again an RFC standard. It is a SSH-based protocol which uses XML to transport data over SSH. So let's talk about Ansible collections. Collections is a standardized way to organize the package and Ansible content. Ansible content here can be roles, modules, module utilities, plugins, and documentation. Collection follows semantic versioning, and they are portable and flexible flexible delivery. So I can combine my collection into a logical entity. Say for one particular vendor, I can have a collection for that vendor. So we'll be talking more about collections and network-specific collections in coming slides. And collection can be downloaded on demand basis. Just like for mobile devices, we have apps stored on the App Store or Google Play. User can download it on need basis. Similarly, collections can be downloaded based on the managed nodes that user wants to manage, either from Galaxy or from Automation Hub. So Galaxy is completely open source. Anyone with internet connection can download it. Automation Hub is for paid subscription users. So what are the contents of collection? So first is the galaxy.yaml file. It consists mainly of information like what is the name of the collection, and the namespace of the collection, then who is the author, what are the dependent collections for this particular collection, and so on. It basically contains all the metadata for that particular collection. Then README is the README documentation. It is a front page and tells what this collection consists of. Then documentation consists of all the plugin documentations for that particular collection. The meta folder again contains some metadata. It contains the main file is a runtime YAML file, which tells what are the plugins that are deprecated or the minimum Ansible core version that is required. Then playbook folder consists of tasks and files that user write, and these playbooks can import the plugins that are part of this collection. Then plugins is where all the heavy lifting is happening. These are basically Python files, and they are divided into logical units. So I will be talking about plugins more into the coming slides. So they are modules, lookup plugins, filter plugins, connection plugins. Then roles is something that user writes and builds the functionality or business logic on top of the plugins by using the plugins. And test folder is basically used to test, have your sanity unit and integration test for your collections. So this slide talks about what are all the different plugin types for Ansible. First one is a module. So module is a discrete unit of code that either runs on managed host or on control node in case of network, and returns the result to the user. We'll be talking about CLI command and CLI config in our coming demo. Then the connection plugin, there are different connection plugins that can be part of the collection. It allows Ansible to connect to the target host so it can execute tasks on them. Ansible ships with many collection plugins, but at a given time, only one connection can be used for a given node. Then lookup plugin are Ansible specific Jinja to templating extensions, and they are used to access data from outside source. So example of this is if I want to read a content of files within my playbook, I can do so using lookup plugins. Then filter plugins are used mainly to transform data. They are mainly used for data manipulation. Examples of this is like if I have received a JSON structure from a remote host and I want to convert it into YAML or some other readable format, this is where filter plugins come into picture. The examples of this are to JSON, from JSON, to XML, from XML, so on. Then test plugins are used to validate data within my playbook. They are against Jinja templates, and the return value is either true or false, whether the data is valid or not. Then inventory plugin allows user to point to the data source to compile the inventory. There are a bunch of inventory systems that Ansible can talk to or hook into. Example of this is AWS EC2. Even if you have Excel sheet as your inventory, Ansible can read your inventory information from Excel sheet and manage the given host. Then callback plugin are basically used to modify the behavior of Ansible based on certain events. So they basically control most of the output you see running on the playbook. You can write your own callback plugins to integrate the output and pass the events onto some external tools for marshalling of the events or storing it into the backend. So with this collection overview, let's move on to network collections. The first one among them is Ansible NetCommon collection. So Ansible is a namespace here, and NetCommon is the name of the collection. So this collection basically holds platform-independent collection, platform-independent plugins. Important among them are connection plugins, the network CLI, NetConf, and HTTP API plugin. Since these are platform agnostic, they are part of NetCommon collection. Then there are filter plugins to modify or check data related to network or IP address. There are modules that are platform agnostic. The CLI config is used to manage the config aspect on the device. Then CLI command is used to run operational commands. Then netconf get netconf config is used to manage the device that understand netconf transport. Then we come on to Ansible utils collection. It basically mainly holds plugins that aid management, manipulation, and visibility of data within Ansible for Ansible playbook developers. So there are modules that are used for data manipulation, like CLI pass. It is basically used to convert plain text data into structured data. We'll be seeing more about this in coming slides. Then validate fact diff. Then there are again filter plugins that are very generic. So there are two XML index of, if I want to get an index of a particular data from my dictionary, I can use index of filter plugin. Then test, there are a couple of network test plugins to check the validity of IP addresses, whether IP belongs to a particular subnet, so on and so forth. So then we come on to a couple of vendor-specific collections. First is arista.eos. It consists of fundamental modules like EOS config, EOS command, EOS facts. So these are specific modules to that particular vendor, and it has certain knobs that are specific to those vendors. So that's the difference between the platform agnostic config modules, config and command modules versus the platform specific config and command modules. Then there are resource modules to manage multiple resources onto the device, like interface, BGP. I'll be also showing some demos around this resource modules. Similarly, there are collections for Cisco iOS, Cisco ISXR, NXOS, Juniper JunoOS, and YOS. And the content more or less remains the same. It's just prefixed by the name of the OS that is running. So the naming convention followed here is the name of the vendor, followed by the OS name and the name of the plugin. In addition to this, there are whole lot of modules or whole lot of collections that is being developed by community, by vendors, by Ansible team, and it is available on Ansible Galaxy for, it is open source and it can be downloaded from Ansible Galaxy. In addition to network content, there is whole bunch of collections that can manage your cloud infrastructure, security infrastructure, edge infrastructure, and so on. So there are 100 plus certified content collections that are available out there. So Ansible is just not limited to Linux or network. Any endpoint that has an API basically can use to manage with Ansible. So I talked about collection. Now we'll go one level deep, and talk about some of the plugins that are part of the collection. So first is the CLI command module. So the fully qualified collection naming convention is a namespace. Ansible is a namespace. NetCommon is the name of the collection, and CLI command is the name of the plugin. So it is basically used to run a command on a network device and return the result to the user. The return result can either be on plain text format or in structured format like JSON, provided device supports that capability. Then it also provides a way to execute commands that require user inputs in form of CLI prompts. If user wants to pass update a software, where each device throws confirmation message whether you want to proceed or no. In that case, it handles those interactive command prompts. Then there are some platform-specific command modules. Example of this is EOS command. So Arista EOS underscore command. Similarly, iOS underscore command. In addition to above functionality, it has some platform-specific knob, and it also has certain options that will allow you to wait when a specific condition is met before returning, or timeout if the condition is not met. So this is basically used to check if an operational state is met on the device or not. Then there are facts modules that are used to gather facts about the system. So this will basically run a bunch of operational commands and then return the data in a structured format. So it will basically return what version or what hardware, what is the image that is running, what are all the interface configured on that particular device. So we'll be seeing this modules in action in coming slides. Then netconf get is basically using netconf connection under the hood, and it basically executes the get RPC that is defined by the netconf RFC and returns either the configuration or state data from the device in XML format. And this module has the capability of converting that XML into a JSON format, which is more readable or more consumable as compared to XML. Then netconf RPC is used to basically execute vendor proprietary RPCs. So in addition to RPCs that are defined in netconf RFC, vendor can have their own proprietary RPCs. So for example, for Juno-OS, there is this load configuration RPC that is specific to that particular vendor. So you can use netconf RPC to execute that particular RFC and get the response back on the device from the user. We talked about operational state modules. This slides talk about the configuration management modules. So similar to CLI command, there is a CLI config command, and it basically pushes plain text command onto the device. It uses network CLI connection plugin, which is again a SSH-based transport. Then in addition to this platform agnostics module, there is platform-specific modules, for example, EOS underscore config or iOS underscore config module. This module basically pushes the configuration onto device in a deterministic way. In the sense, these modules are idempotent in nature. They will first fetch what is the current configuration that is running onto the host, that is running within the host, and it will push the configuration only if there is a change required. So these are idempotent in nature, and they identify whether there is a drift between the desired state and the final state. If there is a drift, only then it will push the changes on the device. Then it provides easy way to back up the running config onto a file that is on a local system. This again uses network CLI connection type. Then the netconf config module is again it is used to execute the edit config RPC that is defined by the netconf RFC, and it returns data, the configuration data in either in XML or JSON format based on if the netconf is enabled on the remote host or not. Again, this will make changes on the device only if there is a configuration change required. If not, it will not push any, not execute any config on the device. So let's see a couple of modules that we discussed in action. So I'll first go through my environment. I have Ansible installed, Ansible version. So this is the Ansible 2.11.6, and I have installed it using pip install Ansible core command. So this will basically install the main engine that is responsible for reading the inventory and executing the playbooks. And it basically has the core engine and a couple of bootstrap modules. It doesn't have any other content. So suppose if I do a pip install Ansible, here is a package that consists of the core engine, and there are a bunch of community collections. There are around 80 collections that are part of this package. But since I won't be using in this demo, I have not installed Ansible package. Instead, I have installed just the Ansible core here. And on top of that, I have installed a couple of collections from Galaxy that I'll be using in this demo. So the command to see the collections installed is Ansible Galaxy collection list. I have installed Ansible Netcommon collection, Ansible Utils, Arista US, and Cisco iOS collection. The command to install the collection is Ansible Galaxy collection install and the name of the collection. So once you do this, it will download the collection from Galaxy. After that, let's see the configuration file that Ansible will be using. So by default, Ansible looks for ansible.cfg file in the current folder, and if it is present, it will be using that file as active configuration. It is also displayed in the Ansible-1 version that which file is an active file. One of the notable things that to look for is the inventory file here. Inventory, I'm pointing to a file here, which is a file that is within my current working directory. And I don't have to pass explicitly. This will basically tell Ansible engine to look where the inventory or the managed host are defined. In my inventory, I have two hosts. So EOS is a name of the group, and the child are individual hosts. I can have multiple hosts here. Similarly, I have iOS group, and I have one host called iOS 01. Then there are these two folders, host VAS and group VAS. So group VAS is where I will store all the variables that are defined for this, but that will be applied for this particular group. And the group name and the file name should be matching here. So it is again a YAML file. Here I'm defining the OS type. For EOS group, I am defining arista.eos.eos and the port that will be used to connect to the Arista host. And then for iOS, similarly, I have defined network OS, cisco.ios.ios. And then moving on to the host VAS. Host VAS are where I have defined host-specific variables. So first is a Ansible user. It is an instance that is running in my AWS instance. So EC2 user. Then the private file that will be used to connect to the device. And then the configuration that will be pushed or that will be used for this particular host. For the sake of demo, I have an interface config as a key, and the fields are name and enabled. I can have a list of interfaces here to manage. Then let's talk about the first playbook. So this is how a basic Ansible playbook would look like. That the network operators or users are expected to write. So first parameter here is host. It tells which host I need to run this playbook against. I have defined all here, so it will basically run for all the groups and all the hosts that are part of those groups. Then connection here is Ansible Netcommon network CLI connection. So I have defined gather facts equals to no. I don't want to gather facts for this particular task, for this particular playbook. Then task is a list of tasks, or it tells a list of things that I need to execute on my remote device that is used for management. The first one here is name. Name is optional, but it is recommended to provide name so as a description of what this particular task is doing. The first thing I'm running is the CLI command module. The command that will be running is show version. It is the output that is received will be registered to this variable, and then I'm printing the variable using the debug module. You can see that there are a couple of auto-completion diagnostic features available. So if I go to definition, it will take me to the documentation file where it is stored. So by default, Ansible collections will be stored under your user folder .ansible. Ansible underscore collections is a top level namespace. Then Ansible is the name of the namespace of the collection. Netcommon is the name of the collection, and then the contents of the file. So same can be seen in my list command. So this is where the collections are stored, and I'm using a VS Code VS Code for developing, and I have installed Ansible plugin, VS Code extension plugin that was recently released by Ansible that makes developing Ansible much more easier. So let's try running this playbook. So I'll be running using Ansible playbook command line and then the name of the playbook. So this will basically run show version on my two hosts, EOS and iOS. And this is how my return result would look like that I have printed using the debug. The HTTP allowance will be the plain text response that is received from the device. This is for Arista, and this is for the iOS XE software that is running in the instance. So this is using 10, 12 lines of code. You can execute command using an automated way by running a script or a playbook, I would say. So let's move on to a bit more advanced modules for config management. This module is the keywords remains the same. In addition to earlier modules, I've added become equals to yes. Since running certain configuration command requires privilege escalation, when I give become yes, it will take me to enable mode and then execute the command that are part of the modules. So esconfig is a module that I'm using to push the configuration. The parent is interface loopback, and the lines that will be the child of this parent is description configured by Ansible and no shutdown. So diff here I have given here, it will we will see what are all the changes that are being pushed, or what are the commands that are being pushed onto the device. Then next command is we'll be running the show running config interface loopback to check if that config has been taken affected or not. And then we are again printing the result here. So let's quickly run the playbook and see what's output. So it has run the configure interface. So this name is coming from the name of the task here. Then since loopback interface was not present on the device, it will push these two lines onto the device. And then since the configuration is changed, it comes as change for EOS. And then we are fetching the interface configuration, storing it in the result, and then we are printing the result as part of debug task. So this is what is present on the device currently. And now, if I run this again, there won't be any changes. And this is what idempotent behavior, idempotency is called all about. So now, since interface loopback is already present on the device, and there is no change task, and previously there was one change task. So this was about configuration and command modules. We'll quickly talk about the facts module. So facts, again, here I will be running again all the hosts. I'm using EOS facts. There are no options that are provided to this particular task, right? And you can provide a conditional statement onto your task. So I want to run this task only when my Ansible network OS is set to arista.eos.us. So this is being set for each of the hosts. And similarly, iOS facts I'll be running only if the network OS is set to Cisco IOS. And then I'm storing the facts result in EOS facts result. I'm printing that here. And similarly, for iOS. Let's run this module and see what is the output. So first task has been skipped because the condition here is not met. It is run for the EOS instance. And for the second task, the EOS instance is skipped. Sorry. Yeah, the EOS instance is skipped and it is running on iOS instance. And these are the facts that are result. So whenever facts variables are set as facts by Ansible, it is prefixed with Ansible_net so as to not collide with user-defined variables. So it has IP addresses, which are all the images or images that are there on the interfaces, images that is loaded on the device, then set of interfaces. You can also mention which are all the subsets that you can provide. You can fetch facts for configuration. What is the BGP configuration, OSPF, so on and so forth. This is a minimal facts that is written by the default facts. Similarly, you can see it has written for iOS instance. So let's move on to the backup. Using EOS config module and providing backup as the option here. When you hover over here, it basically tells what this option is doing. If you set backup true, it will basically fetch the running config from the device and store it on a file on a local system. And again, I have provided conditional statement here based on the OS type to run again, so that correct module is run against that particular host. So EOS config is used to take backup for the EOS host, and iOS config is used to take backup for the iOS based devices. And then after backup is taken, I'm again printing the results for that, just so that it is easier to understand. So right now, there is no backup folder that is created. By default, it will create a backup folder in my current working directory, and then it will store within a file. So the return result basically gives me path where the backup file is created. So if you want to use that file later on, or for sake of further management, it can be used. This is for my EOS instance, and this is for the iOS instance, and similarly the files can be viewed here. So this was about fundamental modules. Let's now move on to what are resource modules and how configuration management is made simpler using those modules. Yeah, so while config modules are easy to use and they augment the skills of network operators in the form of CLI commands that operators are very used to while their day-to-day operation. The problem with that is if you have structured data that you want to use to manage the inventory, you will have to use something called as Jinja templates to convert your structured data into device-specific CLI commands. And if the configuration is large, the complexity of Jinja templates increases exponentially. So after you have this CLI commands, you will basically be using EOS config or config modules to push the configuration onto a device. If the question is there an easy way to do config management with Ansible? The answer is resource modules. So the resource module basically understand what are all the device-specific CLI commands. So it takes structured data as input, then converts it into the vendor-specific CLI commands, and then push the native network configuration onto the device. So with this, the advantage is the operator doesn't have to understand or doesn't have to have knowledge of what are all the device-specific CLI commands that needs to be used for config management. All he needs to do is change the data or the source of truth in structured format outside of the box, and the resource module will take care of rest of the things. So resource module has a couple of states. So first one is a config option. So this example talks about VLAN config management. The first option is config, and we are feeding in here VLANs variable. VLANs is again structured data. This is represented as YAML. You can also provide JSON format. So VLANs has name and ID, VLAN ID. It can be a list of VLANs. So this module basically converts these name and VLAN into CLI commands. And there is a bunch of state that is provided for ease of management. The states are merged, replaced, overridden, and deleted. Merge is to add incrementally onto the device. Replaced is to do a template diff. Overridden is if you want to force a policy on the device. Then delete is to destroy or if you want to remediate something. So let's talk about merge state. So this is my existing configuration on the device, show running show pipe show VLAN. This is output. It has VLAN 5, VLAN 10, VLAN 50. But my YAML source of truth says that I want VLAN ID 5, 10, 20. And for 5, I don't want state to be suspended. So for 5, state should be is suspended here. So the missing VLAN here is 20. When the state is merged here, it will go and add VLAN 20 onto the device, but it won't change anything that is already part of the any key that is already part of that particular resource. So since state is suspended here, it has not changed anything. This is what the merge is doing. But if you want to remove state suspended, you'll have to use the replace state. Here again, 20 is missing from my YAML source of truth. when I run this particular module with state replaced, it will go and add VLAN 20 and name DMZ, but it will replace my VLAN ID 5 config stanza here. It will only have name desktop and state suspended is removed since I'm using state replaced. With state merged, this particular config was not removed. Then overridden is for pushing the policy. It will basically ensure that my whatever is reflected in my source of truth is the actual config that is running onto the device. So if my existing config has 5, 10, 50, 50 is an unwanted VLAN ID. When I run this command with a state, when I run this task with a state overridden, basically it will push 20 on the VLAN and it will remove VLAN 50 from my running configuration. Then state delete, it will go and delete individual VLANs that are mentioned in the source of truth. So I have VLAN 5, 10, 20, and 50 is in my running configuration, but I have mentioned that I want to delete 5, 10, 20 with the state deleted. So it will be deleted from my running configuration and only 50 will be present onto the, will be reflected for the running configuration. In addition to we talked about inputs to the module. The return statement consists of before, command, and after keys. So before, you will basically it will basically run show command for that particular resource. It will get the text response and then convert it into a structured format that the module module archspec understands. Then command is basically delta command set for the device, and after is post the command is being executed and committed into the running configuration, it will basically get the after state of the device, and then it will render it in a module archspec format. So this slide talks about what the return keys. So again, I have 5, 10, 50, and my YAML source of truth is 5, 10, and 20. This is for state merged. If it is merged, I will only have to push VLAN ID and name DMZ. So these are the commands that are pushed on the device. And this is the before state. So running config is a plain text here, and it is converted into a structured format. And these keys are similar to what I'm giving input as input to the task here. So I can use this in my next task if I want to do further management on top of this. And this is the after state. After state it will have an additional VLAN of 20 here. So let's quickly see a demo of resource module in action. So again, the top level keys remains the same. I'm changing what is contained in the task. So here I'm using an interfaces module. So Arista EOS interfaces. So interfaces is a short name, and it is being redirected to EOS underscore interface. This information is present in meta file of the collection. So the first key is the config here, and the value is interface config. This is being defined in the host variable. So I'm using an EOS host, so it will first go and look into the EOS underscore EOS01.yaml file, and I have defined a name loopback and enabled equals to true. For sake of demo, I have just taken simple configurations here, and state is here merged here. I have registered the result, and it will be printed using the debug module to see what are the return statements. So the task is running. It will basically fetch the current interface state, and it will identify if there is a drift or from my desired state. So desired state here is I want a loopback 0 to be present, and the state should be enabled. So if you see the before key, it won't have loopback one is what I want on device. In the before key, there is no loopback one. In the after state, there is loopback configured and state is enabled. And I can see what are the commands that are pushed onto device to make that change happen. Now, if I run this again, I'm expecting that there is no change on the device because loopback one is already present, and I have achieved the state that should be present on the device. So before state is loopback one is there. Since there is no change on the device, the command is entry. The command is empty here, and there is no after key present. So we talked about config state management, how we can do using fundamental modules and resource modules. Now we'll move on to how operational state management can be done using Ansible modules. So what are the common, we'll first talk about what are the common operational state use cases. So first one is retrieve the source of truth. So collect the current operational state from the remote host, convert it into a normalized structured data, and store it as inventory variables to be used later on. Then after we have retrieved the operational state, obviously the next step comes is a validate. We want to validate whether the operational state is meets our criteria. So it will basically define the desired state criteria in a standard-based format. It will retrieve the operational state at runtime and validate the current state data against a predefined criteria to identify if there is any deviation. If there is a deviation, then it will move on to remediate state. So it will basically push certain configuration to remove that drift, or it will report to an external system for any user intervention. So a couple of operational state again use cases are if I have to make changes to a device. So I will make changes only if the operational state is met. So example of this is make a configuration change if all the BGP neighbors are healthy. Then if I want to perform a fleet health assessment, for example, if I want to check if all the configured NTP servers are in sync, then post-change validation. After configuration change is done, if I have to see if that is converted into a conversion into an operational state. So LLDP OSPF neighbors and its reachability has not changed due to that particular change. Then again, custom reporting using templates, the interface config state versus configured state. We'll be seeing about this particular use case in our demo. So this slide talks about which modules we'll be using for doing this. The first one is the CLI pass module, that is part of Ansible utils collection. So this module basically takes a plain text response and converts it into structured data. It works with all kinds of devices, network, Linux, or Windows host. It supports various parsing engines. There are a whole bunch of parser engines that are available there that are open source. This module leverages those parser engines. We'll see what are those parsing engines in coming slide. And then this single task is used to run the command, pass that command, and set as facts into Ansible ecosystem to be used later on, and returns the structured data from show command output. So this is how the module would look like. So the CLI pass module takes command as one of the options, and command here is show interfaces which will be executed. And the parser is a top level key, and it has two subkeys. Name is the name of the engine, parser engine that will be used, and set facts is the name of the key that it will be used to set the received facts. So these are all the parser engines that can be provided as part of name here. These are supported by the collection itself. You can write your own parser engine, and it can be used with this particular module. The first one is a TextFSM. It is a Python module for parsing semi-formatted text. It is a well-known parser library. Then again, TTP is again one of the well-known libraries for template-based parsing. Then there is a native parser engine that is developed, and it is part of Ansible NetCommon collection. It doesn't rely on any third-party libraries. So this parser engine is basically used by the resource modules that are built to basically convert a text-based data or response into a structured format. Then Ansible NetCommon and NTC. So NTC has defined a bunch of predefined text FSM templates and are packaged as Python library. Then PyITS library, that is Cisco Test Automation and Validation. You will have to install a PyITS library, Python library for this to work. And XML is again, it is used to convert XML to JSON data using XML to TIC Python library. So this is how parser engine or a CLI pass module will work. It will get a network device output. Basically, show interfaces is run here. It is a plain text response, and then it is passed using the native library, native parser engine. So Ethernet 1 is being retrieved from the output, received output. Then hardware is a key of Ethernet 1 MAC address and so on. So bunch of regexes are applied on this particular text output and are converted into YAML format or JSON format. This is using a native parser engine. So this is how the template would look like here. So as I mentioned, there are a bunch of regexes that are applied, and the result is being stored in a structured format. So this is for a native template. If you are using a PyTS template or libraries that come with predefined templates, you don't have to write your own parser engine, parser template if that particular command is supported. So this example shows show IP BGP, and it is using PyTS Python library. Since this command is supported by this particular library, I don't have to write any explicit template. It will basically, by default, provide read the text output and give me the rendered output in a structured format. For this to work, again, I have to install a PyTS and Genie library. So after I have structured data in my inventory as host variables, next up comes is a validate. Validate step can be performed using the Ansible utils validate module. Again, it works with all the platforms, Linux network systems. It follows an extendable system. You can write your own validation engine, and it can be hooked up into the validate module. Currently, it comes with JSON schema validation engine out of the box. Once you install Ansible utils collection, you can just use this JSON schema validation engine on top of it. So it is basically a single task, reads the structured data and validate it with data models. The return is basically a list of errors in case there is the desired state of operational state is not matched, or success in case the data is valid. So this is structured for validate. So validate has data as the option. Data is the data that I have fetched, operational data that is fetched from either it is fetched at runtime from a remote host, or it is prefetched and kept as an inventory variable. Then the criteria that should be applied on top of this data. It can be a list of criteria, and this criteria should be in according to what the engine we are using. So in this example, I'll be using JSON schema. So the criteria.json is a JSON schema format, and this is a lookup plugin filter. I'm using a file filter here, and it will be a plain text. So I'm converting, since this module expects the criteria to be in JSON format, I'm converting it into from JSON filter plugin. So we had talked about lookup and filter plugins earlier. So this is used for data lookup and transformation. So right now, JSON schema is a supported validation engine. We have a bunch of other validation engines that are in pipeline. Hopefully, we'll be having a Yang parser validation engine pretty soon. So let's quickly see an operational state assessment demo. For this demo, I'll be using this playbook. I'll be running this playbook against iOS host. I will run this playbook since it will take a bit time to run, and I will walk you through what the playbook is doing. So first is a CLI pass. It basically runs the show interface loopback one command, and it is using PyTS library to convert it into structured data. I'm storing the result as the iOS PyTS show interface, and I'm printing it here using the debug task. So the value passed data will be stored as the key of passed here. So the playbook has run. Let's now step by step go through what has happened here. So fetch interface state and pass it using PyTS. After it is passed, they stored in this variable, and I'm printing this variable as a passed key. So the currently loopback one is configured on my device. So since I'm running a loopback one interface, and it is giving me a bunch of facts about that interface. Notice here the state of the interface here is false, and the upper state is down. So next comes the validate state. So validate here, whatever data I have fetched from my CLI pass task, I am feeding it as data to the validate module using the data key. And the criteria is basically stored onto my local system. It is within current working directory validate criteria. Let's see what that criteria is. So this is a JSON schema format, and the criteria here is for any of the interfaces. So this is a key here. It matches, it is a regex basically match any of the interfaces. And for all the interfaces, I want my operational state to be up. So this is my criteria. This is a simple demo criteria that I have defined for sake of demo. and this criteria is being used as part of validate. I can give multiple criterias and multiple JSON schemas, and the engine is here JSON schema. So after this is run, since my criteria is administrate up and it is loopback one is not adhering to that criteria, it will result in error. So I'm providing ignore errors equals to true, so that the playbook run is not stopped. It will move on to next task. So the output of this particular task is in red since there is an error. It is written a bunch of errors. So it is a list of errors, and it says tells me where exactly the error has happened. The data path is loopback upper state, and upper state expected is up, but it is found in down state. So then I'm going and running this task on the validate result to identify which exact interface is being failed. So I'm looping over the list of errors list here and fetching the data path and splitting it into splitting the value to get the exact name of the interface. And it basically prints me which interface is not in accordance to my criteria. Now, this is again a conditional task. It will run only when there are errors in my validate result. And for all the interfaces that are not as per the desired state, I'll be running those interfaces. And this is basically the remediate state. I'm using the iOS interface resource module to do remediation. I'm passing enabled equals to true here. And again, it will run only if the validate state is failed. So this is basically the output of configure interface. So here it is showing the before and after step. So before, if you see loopback one, enabled state was false. It has identified that, and it has executed interface loopback no shutdown command. And this is the after state, enabled equals to true. And since there was a change, it is reflecting change equals to 1. Now, if I run this playbook again, since my operational state is already in the desired format, there won't be a remediate step here, and change will be 0 here. So this ensures that playbook is idempotent. So yeah, we talked about basic use cases using fundamental modules, then scoped config management modules. So basically, the goal here is to start small. You can start with config, backup, and restore. So it will basically help you gain confidence in automation quickly. There is not a lot of learning curve here to just get started with Ansible. You will first quickly start seeing the value with using network as code, quickly recover the network from steady state using config, backup, and restore. Then comes dynamic documentation. So using facts, you can gather facts for the system, and it is read only and no production config state. You can dynamically generate documentation for sake of reporting and understanding the network. Then comes the scope config management. So it is focused for high yield victories like automating VLANs, ACL, SNMP, introducing source of truth concept. So basically right now when you're logging onto a device and run a set of CLI commands, your source of truth is on the device. With this, you can move your source of truth from device into a structured format outside of the box in a version control system. And with this 3 steps, you can start your automation journey. It is a journey that the team or organization has to go through. There are high use cases that allow network operators to see how much powerful Ansible can provide their team. It brings a using these 3 use cases. It can essentially bring a change of culture to network engineers and make them think differently about network and how network exists within the IT infrastructure. These use cases are extremely simple but incredibly powerful. As soon as you start as a network engineer, you start doing this, going through this journey, you will soon realize how powerful they are, and you'll quickly move on to more advanced use cases. Once you have this basic things up and running, next you can move on to network compliance. It will basically be used to respond quickly and consistently for your security and config compliance. It removes the human error from security responses, and you can enforce configuration policies for business needs and for hardening. Once the config management thing is taken care of, you can move to operational state validation piece using schema validation and enhanced workflow. After this is there, you can move on to automated NetOps, wherein you can hook this system into CI/CD pipeline and do GitOps for network automation. It will be basically doing infrastructure as automation, infrastructure as a code thing using Ansible. So these are the references I have used for the sake of this presentation and for the demo. The things are pretty well documented on Ansible site, and there are a bunch of huge list of open source material that is available. For questions, you can reach out to me on my mail ID, ganesh64@gmail.com, or you can reach on IRC. I generally hang out in Ansible Network IRC channel. My nick is Ganesh RN, or you can reach out to me on Twitter, Ganesh64. I'm not that active on Twitter, but if you want to ping me, I can respond to you there. So that's all I had. Thank you for listening to me, and thank you for your time.